Good morning, everyone. I am going to give a lecture about wind energy resources. We know the renewable energies is we have two energy resources are available. One is renewable, another one is non-renewable. So wind energy is the one of the renewable energy resources. So these are all the content in the wind energy resources, wind turbines, environmental impact and conversation. Finally, the windmill performance and the applications. So these are all the course objective of this course, and the textbooks and references followed for the same course. And initially, before going to the what is wind energy, what is renewable energy, we know the some history. So this energy is started from 1850 also. That time they are erecting and they are using wind energy as a renewable energy resources. After that 1850, after that 1930, they are using nearly 6 lakh units are installed to getting the wind energy as a renewable energy resources. After that 1396, they are also using for the rural areas also. Nowadays, they are using more areas and we can get the more renewable energy resources from the wind energy. So what is wind energy? All renewable energy sources are ultimately come from the sun except the tidal and geothermal power because it's come from other sources. So most of the renewable energy can be ultimately come from the sun sources. So from the sun the earth getting energy, it receives energy like 1.74 into 10 power 17 watts. So this is a big energy sources. So from that sources, as a wind energy is only using 1 to 2 percentage of energy that is converted into wind energy. So already I told you there are lot of renewable energy resources are available like sun energy, wind energy, geothermal, biomass and tidal energy. So compared to the bioenergy, this 1 and 2 percentage of wind energy it is more than 100 times of the biomass energy. So this is the advantage of using this wind energy. And what is mean by wind? So we know, so the differential heating of the earth's surface and atmospheres includes the vertical and the horizontal air current that are affected the earth rotation and it onto of the land also, that is called the wind, like a wind, sea, breeze cycles. So this is the wind. So using this wind, how it can be convert the energy? So we can collect the wind from one source. After that it can be converted into another source. So what does mean by that? The wind energy. So this wind energy is converting of wind power to the electrical power using some mechanism. What is the mechanism here? It is a windmills or turbines. So this energy is converted. This energy is converting to electrical power using this turbines. So this can be transmitted to the transformers and the transmission lines. This is the wind energy simple form. So okay, we should know what is windmill and turbines, right? So the main design is to based on the efficiency how it can be worked. And one has to design the windmill, they have to know the size of the turbine and the size of the generator. That is the main thing here. So this windmill capture the wind energy and then uses as a generator to convert into electrical energy. This is the windmill design, right? This is the one example shows the wind turbine how it can be worked. So in this, these are all the blades. So I will explain how many blades and how directions are here, how many directions are, how categories it can be. I will explain later. So here these are all the blades and rotors are available in the wind turbine. If the inflow of wind in the direction, the rotors and the blades are simply initially start rotating. After that rotation increasing, what will happen? It can be moved into the sea. What does mean by sea here? It is the spin of the main shaft also provided here. Another one is a gearbox also provided. Finally the generator. So it will spin the shaft and it will spin the generator also, that will be using as another rotation, another input of the generator. Finally this generator produce the electricity. Using this wind blade, it can be It can be started, it can be used to rotate, it can be initiate the shaft and the gearbox. After that, it can be used as an input device of the generator. Finally, the generator can be transferred the wind energy to the electrical energy. This is the example of this. This diagram also explains the same thing. Like a wind turbine, it can be get the wind direction, we can change it, and the gearing box and the coupling, the control signals are followed. After that, the electrical generator are using this generator is converted the wind energy to the electrical energy. So this is a one black diagram to explain this conversion system. So once we have to know the different components of working wind turbine, right? So first of all, what is the input here? Wind. So we have to measure the wind speed. Based on the wind speed only, the different conditions of the energy output can be based on that only input, right? So what is the input here? It is a wind. So we have to measure the wind speed and transmit the wind speed data to the controller here. So that is the anemometers here. So it measures the wind speed and transfer. Next process is going to the, this wind is going to the blades, right? So here it's mainly 2 or 3 types of blades are most preferably used in the all wind turbines. So the wind blowing over the blade, it causes the blade to the lift or rotate or move or round. It can be rotated using the wind speed, right? After that, it is a brake. Why it is providing here? So, if any cases of emergency of rotor, any problem, we have to stop the operations. It can be any type. It can be a mechanical or electrical or hydraulically, whatever it may be. But we have to stop the rotor if any case of emergency period, we should apply brake. So, that is the purpose of providing brake system here, right? Another one, controller. What is the controller? So initially we have, so here they are mentioned some of the values. Just we should know the values first. So the wind speed about 18 to 16 miles per hour mph. So initially the controller, what is the role of controller here means the controller start up the machine at the wind speed of 18 to 60 miles per hour. After that it shuts off. So after that the machines are started, it is running about it up to 55 miles per hour. There is no issues here. The controller started and end up, and it can be moved, it can be the generating the electricity. This process is going. If the turbines should not operate at the wind speed of 55, because it may be damage the blade and rotor section. So we here the main purpose of controller is they have to check the machine operations in the miles per hour. It may be above 55, within the 55. That is the purpose of here. We are providing controller here. What is the gearbox? Here also we have some conditions, some technical category here. So gears are connected to low speed shaft also and high speed shaft also. Because here, what is the low speed and high speed? Initially, in the increasing, we have to shaft and increase the rotational speed from 30 to 60, the rotation per minute rpm, to about 1000 to 1800 rpm. This speed is requiredly most of the generator to produce electricity. So this is the main condition here. So this rotation is needed here for producing electricity. It is very costly. So this is the shaft condition provided here. Another one is generator. This also can have a different condition here. Off shelf inductions, high speed shaft and low speed shaft. Based on the condition, based on the RPM, it can be varied to producing electricity. So these are all the main. There are a lot of components are available. These are the main components of producing electricity by using the wind speed. So here we can see there are two categories of the wind turbines are available. So based on the wind direction, it can be changed. But initially we have a two category. One is vertical axis turbine. Another one is horizontal axis turbine. We can see the different types in each and every one, right? First, we should know the horizontal axis wind turbine. So usually we all seen as a three blade system arrangements in horizontal axis turbine. So this is one blade and two blade and three blade and multiple blades are available. If you are getting more wind, mean we can provide this kind of blade systems are arranged. So due to the wind direction, depends upon the wind direction, it can be producing electricity. So mostly we are preferring two or three blade system. So this is the another types of vertical axis turbines. So it's H and delta and diamond. So if we are providing vertical axis turbine, they prefer only the diamond axis, diamond direction turbines, and this Y and pi shaped turbines. So this is a simple explanation, simple clarification in the wind turbine system types. So we can compare in this horizontal and this vertical. We have some items here. So with this, using this item, we can compare. So if your output, you are mainly focusing of the output, power output, what will happen in the horizontal, what will happen in the vertical. So it is wide rangely output. We can get wide range, it is narrow range. But from the starting, we have to initiate, we have to start. Self starting is required because of the wind speed varying, the rotational also it is limited. It is we mentioned, right, the 16 to 80 miles per hour. At the time we have to start the system using controller. We have to start, after that it reaching to the 50 miles we can shut off the controller, right? So initially we need the self starting system. There is no starting here. Then we can get the higher efficiency in the horizontal wind turbine. Compared to that, it little lower. And also the cost wise also, it is lower construction cost, it is higher cost also. The shaft, the rotor is applicable here. How it can be rotated? It runs, it is a horizontal axis, mean it can be run in horizontal, it can be run in the vertically. There is no confusion here, right? So in this wind direction we have to more clarify that, because we have to need redirected. How it can be redirected? So if for example we can take it as a clockwise or anti-clockwise. For example, I am telling it is a clockwise, anti-clockwise. Due to the wind direction, we have to redirect the section. We have directed the blades and the rotors. So we directed when the wind change its direction. But here there is no redirected, the redirected conditions here because of the wind direction. But because it's rotating only vertical axis, there is no need here itself. And here we have to operate only some moderate range and high range. But here operate we can in the low range also. In the vertical turbine we can be operate, right? The generator and gearbox also, it can be provided in the top of the tower. You can see this section all provided in the top sections. At the gearbox, it can be located in the lower bottom of the sections. And the horizontal vertical axis is somewhat difficult to the maintenance purpose. It's somewhat easy. So these are all the simple and differentiation of the horizontal and the vertical axis turbine. So using this increasingly significant power source means it is a well and good advantages using the wind energy as a renewable energy, because it needs the nation electricity in the 6% by 2020. This is most appreciable one, because it satisfied 6% of the nation electrical energy only using the wind energy. So we already seen the different types of wind turbine with the vertical and horizontal axis. This is the sizes. Based on the sizes, how it can be classified because of the application, right? This is small and intermediate and large. The small means less than 10 kilowatt, up to 250 means it can be in, say, as a intermediate, and then above that is mean it can be in large sections. Based on that condition, the usage also varied, the application process also varied. It can be used only for the domestic and remote application. This may be distributed power also, it can be another sources. So finally we can see the advantages of wind power. So wind, we can get the day and night process. It allows windmill, it produces the electricity throughout the day. There is no difference in that. But the output can be mainly based on the wind flow varies. If the vary means the wind flow also varies. The most rapid variation will some extent to the compensated by the inertia of the wind turbine rotator. Okay, the wind energy is a domestic because it is a renewable energy. It is a renewable or non-renewable? It is a renewable energy sources. It does not generate any pollutions, and also there is no effect in the environmental effect also. Up to 95% of land we can use for the wind turbine installation. There is no issue in that, and also we can use the same land for another agricultural purposes like farming, forestry and ranging. This is the one best advantage of using wind turbine, right? So these are all the main advantages, and decreasing the cost of wind power and the growing interest in renewable energy sources should ensure that wind power will become a viable energy sources in the worldwide. It is the one advantages. So we can compare the advantages and disadvantages. Each and everything will have some advantage as well as some disadvantages. We already explained these advantages, right? Wind is free, there is no fuel needed, does not produce any waste or greenhouse gases, there is no environmental effect, and also the land is used for occupying another purposes. It is maybe tourist attractions and good method of producing energy. So these are all the advantages. So what will be the disadvantage? The main disadvantage is the wind is not predictable at all some days, right? That is the one. Another suitable for, if we are providing land means it can be, and land is, if you are locating or nearby the coastal area, the land may be expansive one, and it can be affected the, can kill birds, and also it will affect the migrating process of the birds. So this is the major one problem, and it can affect the television stations if they are locating very near means it will be affecting. And some noise pollutions are producing while generator using means some noise pollutions are producing. So these are all the simple disadvantages. Compared to the environment impact, because there is no greenhouse gases produced, so there is no emission of carbon dioxide, so there is no effect to the environmental. It is 1% of the coal or about 2% of natural gases are produced to getting generating the electricity. Then finally we have to choose the site means we have to consider some factors. We have to choose the site. So the what are the technical factors are affecting the site selections? High average wind speed, low cost construction, close distance from the utility lines and also the customers, prevailing wind direction, surface roughness and obstacle height. So these are all the some factors to we have to consider for the site selection. And these are all the natural characteristics of the wind energy. That is that wind speed, height and density of the air and the blade swept area. So these are all the some characteristics. So if we are using this turbines constantly improving, nowadays they are using the larger turbines and specialized blade designs based on the wind direction. It can be specialized designs are available, and power system, power electronics we are using, and nowadays we can get the system from the output as a computerized modeling. It can be more efficient design also, and some of the manufacturing improvements also included in the design. So due to that it improved capacity factor. So it may be due to this improvement, may be due to better sitting, larger turbines, energy captures, latest technology advantages and high reliability. Finally the capacity factors also increased. Then so these are all the factors in the previous, but our aim in now at present, our India is aiming 140 gigawatt by in 2030. This is the main aim. In 2020, it is 1 lakh. It is 20,000 total turbines are installed. Due to this condition, it needs this total renewable energy sources. It is 6%, but now it can be moved to 140 gigawatt in 2030. So this is the expectations of the future. After that we can install this is in the future of wind. It can be used in the offshore structures. It may gravity foundations. The shaft can be in stable unstable positions, and it is artificial draft, and this can be used as an offshore structure is another future goal of the wind energy resources. So these are all the course outcomes of the structures. And thank you.